This is lesson 6.4 out of the Decimals and Fractions book. If you're in Mrs. Walker's class, the notes start on page 56. This lesson has 2 pages of notes. And so the title is lesson 6.4, Nets and Surface Area. We usually teach this lesson in 2 parts as a 2-day lesson, and I think once you start seeing the lesson, you'll see why there's a lot in this lesson. And for some people, it can be challenging. You're really kind of asked to think about shapes in a different way. How would you picture a 3-dimensional shape all flattened out into 2-dimensional? And that can be a way of thinking that comes natural to some people and not so much for other people. So it can be challenging, but I've got these notes built out well, and we'll just dive right in. We're going to start, of course, with the warm-up. So warm up. And warm up has 3 problems. First one is, well, I'm going to draw this little figure here, this parallelogram, and a dotted line to show the height with my right angle square there. The height is 7 meters. And the base is 12 meters. And let me get some more light on that. I'm not sure that's coming out very well. Okay, here we go. And the instructions are find the area. Okay, and there are 3 problems here. Each one, the instructions for it are find the area. So problem number 2 is a triangle that looks kind of like that. And it has a base of 9 feet and a height, which we need to draw this little dotted line here and put in our square, a height of 6 feet. Which that doesn't look proportional at all, does it? If this is 9 feet, well, maybe not. That's not too far off. Anyway, doesn't matter. We go by what the labels say. So find the area of that. All right. And problem number 3 is a square. And all of these are 90-degree angles, so it's got little squares in it. And it is 3 centimeters. This is a square. All right, so find the area of all 3 of those. We have 2 I can statements for this lesson, and that kind of feeds into why we often teach it in 2 days, because there really are 2 different sets of skills we're learning in this one lesson. All right, the first one is I can draw nets for solids. You'll find out what that means soon. What do you mean nets? Well, the nets is a 2-dimensional drawing of a 3-dimensional figure. So the second one is I can find the surface area. Find the surface area of a solid with nets. That means with using nets. To kind of squeeze that in there. All right, my dark green pencil signifies that's the end of our warm-up, and we're ready for our lesson. So The first thing I'm going to do here in the lesson portion of our paper is I'm going to cut out this notes that has the vocabulary of solid, polygon, face, and base. And instead of putting it up here in my usual area, I'm going to put it right in the center of my notes area here. So that's a little bit different than we usually do. Put it right in the center, and it'll become obvious why I'm doing that here shortly. Oop. Okay. Tiny tadpoles. And in the center. Okay. All right. In the center of my notes area. All right, so this is some vocabulary that we need to make some notes of, because we've got to be able to understand all of these terms in order to understand what we're doing in this lesson. So we're going to start with a solid. So a solid is a three-dimensional figure that encloses a part of space. So it has volume inside of it. It's not just a flat shape. So there are all different kinds of solids, cubes and cylinders and pyramids, all shapes that enclose volume of some kind, right? So an example of a solid, and you guys are just going to have to excuse my drawing. I do the best I can, but it's not my strong point. An example of a solid would be a cube. And to make a cube, you start with a square, and then you make little diagonal lines that you kind of line up here. Here's the back. Okay, and then here's the back of my cube. Okay. Not too bad, right? Not too bad. I can neaten it up now with my blue pencil. So here's my cube. And my cube has many sides, and we'll talk about all the sides of a cube when we talk about this solid as a net. But there's my little cube. And that would be an example of a solid. Okay? That's just an example of a solid. There are many different kinds of solids, but that's an example of a solid. Okay? All right, now the next one we're going to talk about is a polygon. We've talked about polygon. We've defined polygon before. It's a closed figure made up of three or more line segments. Polygons are just a two-dimensional thing, not a solid like a cube. So examples of a polygon would be, let's say, a triangle. It has three or more line segments and is a closed figure. This parallelogram is an example of a polygon. This rectangle is an example of a polygon. Okay? All of those have three or more sides and are closed figures. Okay? So they are polygons. So examples of polygons would be this and that and this. Okay? Polygons. All right, now we're going to talk about what is face, the face of a shape, okay? It is a flat surface of a solid, right? So this is the face, a face on this solid. This is another face on this solid. This is another face on this solid, right? So I'm going to draw an example of well, I'm just going to put over here another cube and color in what would be one face on this cube. So I've got my cube. There's my cube. And if I colored in only this one side is one face of this cube. That's another face. That's another face. Every side, every surface area is a face on a solid. So that's an example of face. All right. Okay, I'm gonna make this stand out a little more so you can tell I mean right on that side. There we go. All right, now base. Base can be considered a face, but it is a face that's often located on the top or bottom of a solid. It can be either polygons, that would mean line segments, or circles. And I'll give you an example of both. All right, so I'm going to try and draw a pyramid solid. It's not easy to do, so bear with me. All right, so here's my base, and the corners go up like that. Okay, there's my pyramid, and so the base of it is down here on the bottom. That's the base, the bottom that the pyramid goes up from. It's not the greatest pyramid, I know. That's not one of my better ones. Okay, but now it said something about the bases can be either polygons, meaning shapes like these, or circles. So can you think of an example of a solid that has circles for bases? Well, there's a couple I can think of, but the most common one that comes to mind is a cylinder. It has a circle for its base at the top and the bottom. Oops, I need a little more lead. Hold on. So top and bottom of a cylinder. So I put two circles and then draw down its sides. There's my cylinder. Now this has a base at the bottom. This face here would be considered a base. This face here would also be considered a base. Okay, so those are examples of a base on a solid. Sometimes a solid will only have one base, like pyramid shapes. Sometimes they'll have two. So the base is this down here. Right? Another example of one with circles is this here and this here. Okay? Those are our bases. All right, so that gives us an idea of all the terminology that we need to move forward on this lesson. So that's page 1 of our notes. Let's get started on page 2, well, what is going to be page 57 in my class. All right, let me put that aside. And now we've got page 57. Page 57. All right, so on the next page, we are going to put, there are 2 notes sheets that have all these shapes on them, vocabulary and vocabulary continued. And we're going to put them right up at the top here, side by side, starting with the prism, and the side that goes next to it is the one with the cones and the spheres. Okay? That's how we want them to be. So give me a minute while I get them glued into place. The beauty of videos, you can always kind of fast forward through this spot where I'm doing this and pick up when I start describing it all again. Alright, so there's the first one. And the next one right by its side. Okay, so now I've got them where I want them. I'm going to take my yellow highlighter and highlight the titles on these. And then we'll start talking about what all these different shapes are. So with my green highlighter, I'm just going to quickly go through and highlight the shape names. We've got prisms, we've got pyramids, we've got cylinders. We've got cones and we've got spheres. And then we'll highlight with, let's see, I'll take my red pencil and just circle the keywords and their descriptions. Okay, what makes a prism a prism? What makes a pyramid a pyramid? All right, so prisms. Definition here says a solid formed by two congruent parallel bases and rectangular sides. Wow, what does that mean? All right, so here's the main deal we're talking about here. Parallel bases. Right? You'll notice that every one of these prism shapes has a bottom base and a top base. A bottom base and a top base. No matter what shape those bases are, there's a bottom base and a top base because the sides are going to be straight up and down. So parallel bases is our primary keywords for a prism. All right, a pyramid. A pyramid is a solid with a polygonal base. Polygon, remember what a polygon is. So that could be many different shapes as long as it's at least 3 line segments in a closed figure. A solid with a polygonal base and triangular sides that meet at a vertex. That means they meet at a point at the top. So our keywords on that, sides that meet at a vertex. There's not going to be a base at the top. There's going to be a point, a corner, a vertex at the top. Now the base might be many different shapes. This one has a hexagon base. This one has a triangular base. And this one has a square base. So these pyramid shapes can have many different shapes to them. What makes them a pyramid, though, is that their sides are triangular, all going up to a vertex, a point at the top. Okay, a cylinder. A cylinder is a solid formed by two congruent and parallel cylinder bases. Congruent means the same. And parallel means that they are side by side. All right, so we talked about the cylinder a little while ago, and these are all different shapes of cylinders, but depending upon the size of the circles or ovals, you'll have a slightly different shape to your cylinder. But what makes it a cylinder is that they have parallel circular bases. Right? So parallel. So this circle and this circle is parallel. Base on the bottom, base on the top. Okay? This circle and this circle, they're parallel. Base on the bottom, base on the top. They just have it laid on its side. This one looks larger, but still has the same setup of parallel circular bases. That's what makes it a cylinder. Now, you can also, there's another shape that also has a circular base, but it does not have two parallel circular bases. There's only one circular base, and that would be a cone. So a cone is a solid formed by one circular base at the bottom and a curved surface which connects the base at the vertex. So a cone is going to have a circular base and the surface goes up to a point at the top. All right? All right, so a solid, let's see, what would be the keywords there? Circular base, one circular base. That was and then vertex. We'll underline vertex. Okay, one circular base going up to a vertex. Okay, so a sphere. In mathematics, a sphere is we kind of know what a sphere is as a ball shape, right? But it has a very specific definition in mathematics. So here it says a solid formed by a set of points in a space that are the same distance from a center point. So I'm going to underline same distance from a center point. What you have to imagine is that if you were holding a basketball and you were able to suspend, let's say, a little BB in the very center of the middle of that basketball, and then from that BB you measured out from it to the inside walls of the basketball in any direction. Well, if it was right in the center, it would measure the exact same measurement in any direction out to the inside wall of that basketball. That's what makes it a sphere. Okay? Okay, so we've defined those shapes. Let's move on to talking about what a net is. We've used that term a few times, and we haven't really talked about it, all right? So, so on this one, let's see, what did I do with that? I wanted to cut off the section here. We have these shapes and then these blank boxes and a definition there. I'm going to cut off this section so all I have are these flat looking shapes. We'll write and discuss what's kind of missing in that notes there. It's kind of useless to us because it didn't really print right, but it's okay. I'm gonna use my dark green pencil and draw a line under here because we're kind of now done with talking about these solids. Now we're going to talk about nets. All right, so can you see that? Let me zoom in here just a little bit more. There we go. Oh shoot! All right, sorry about that. My zoom isn't very touchy. I don't know. Let's see if that works for us. Okay. So can you see how I cut that off there? Now I'm going to glue it in the middle, right up next to the green line. Okay, so the vocabulary we're talking about here now is a net. And again, we'll outline here. Lots of vocabulary in this lesson. And we're talking now about what is a net. It's not something you catch fish with. Nope, we're talking about something very different here. Okay, a net is a two-dimensional pattern that can be folded up to form a three-dimensional figure. So basically, what we're talking about here is if I looked at any of these three-dimensional figures, these solids, if I unfolded them into a flat piece of paper, what would they look like? And so that's where your imagination starts to come in, trying to imagine how you would do that. Now we think about it the other direction here. If I folded up these figures that you see here, what kind of a solid would they form? And you'll be thinking about these things in both ways, but there's a handful of them that you'll begin to recognize, you'll begin to just know. So don't worry right now if you're looking at this and thinking, what the heck? You'll begin to just recognize them. All right, so I'm going to try and draw then. This net here, the two-dimensional unfolded, is what we call a net. This net, when folded up, creates a solid that looks like this. Well, I can see that it has four sides here. Okay, I know that it looks, and they're long. Okay, it's got long rectangles, and then it's got a top and a bottom. That's this and this. Okay. So it is forming a tall what? Remember, parallel bases. It's got a bottom and a top there. So it is a prism. It's a rectangular prism. So I'm going to try and clear that up just a little bit. Rectangular. Oh, I did not do that well. Oh, not my strength. That's not too bad. I'll color it in, you won't be able to tell. Rectangular prism. Okay, so it's much like this one they're picturing here. Okay, this solid they're picturing here, if you unfolded it, would look like this net here. That's what I was trying to draw. Maybe not that successfully, but we're going to pretend it looks fantastic. All right, now, this one here, I can see a base. Can you? The base is this, oh, my pencils are moving around on me. All right, the base is this shape right in here. And then these sides fold up. This side folds up, creating the top that flips up over the top of the solid shape. So, oh man, I don't know if I can draw this one. So, so I've got a base that is a six-sided hexagon, and it's going straight up to another hexagon at the top. Man. No. So, I hope I have an artist in my class somewhere that can draw these up on the board for me, looking much better than what I just did here. But hopefully you can picture it as a six-sided barrel. It's the best I can do in describing. We don't have a good example of one up in here. Probably that's as close as it comes. That looks like a pentagon shape, not a hexagon. But if it was six-sided, it probably looks somewhat like that. All right, so that's our example of this one. All right, now next one's a little easier. Okay, I have a circle base and another circle base. I got two circular parallel bases. So as I remember, two parallel circular bases means it's going to be a cylinder. So one base is down here, the other base is up here, and the sides are here. Okay, this long rectangle is what wraps around, making the side of our cylinder. So once you have that pictured in your mind, you can see how that net folds into a cylinder. All right, this one has a base. It has a square base and triangular sides. So when you fold up those triangular sides, they're going to meet at a point at the top. That means we have a pyramid. This one in particular is a square period. So my square base going up to my pyramid. That's my square pyramid. All right. So this net turns into a cylinder. This net turns into a pyramid, a square pyramid. All right. Okay, so dark green pencil. We're done talking about nets right now. And we'll have some fun with nets in class. I'll have a whole bunch of nets that you'll be able to fold up into solids and get a better picture than with my drawings of how these work. Okay, so our lesson had a second I can statement, and that was I can find the surface area. And so that's the last part of our notes. We're going to talk about surface area, how to find it. All right, so I'm going to write here with my black pencil, find the surface area, find the surface area of a solid. Okay, now, what does that mean, find the surface area of a solid? Well, it means I'm going to find the sum of all faces of the solid. And remember how we, oops, that looks, let me write that a little clearer. Remember how we defined what a face is. It's one side of any solid, of the solid. There we go. All right, the sum of the solids. I'll just put that, whoa, pencil, come back, in parentheses there. You know, what does that mean? All right. Now, there are steps to doing this. And the first step is, we'll go problem 1, light blue, circled 1. The first step is to draw a net of the solid. That is always the first step. So draw a net of the solid. All right, so let's say we're dealing with a cube, because that's the easiest for me to draw. Well, what you would have to do is draw the net of a cube. And the net of a cube, it has 4 square sides and a top and a bottom. And the top and the bottom on the net, it could be attached to this square, this square, this square, that square. It doesn't matter. Sometimes you'll see it on the end of the 4 squares, and sometimes you'll see it looking like this little cross figure. But it doesn't matter, because once you bend around these 4 squares that make the sides, then this flips over to be top, this flips up to be bottom, and it doesn't matter from which square that happens. So that is a net of a cube, one way to draw it. Now, step 2 would be, step 2, record the measurements of the net. All right. So now I'm going to make my net a little bit bigger here. Okay, so let's say that it's a cube, so I know the area of all of these faces is the same. So I'm going to record that it is 4 inches by 4 inches. So I know what one face of this cube is. The area would be found by multiplying 4 by 4. 4 times 4. Okay, so with my brown pencil, then I'm going to write step 3. Step 3, oops, get up here. Step 3 is find the area of each part of the net. Okay, so I know that one face is going to be 4 times 4, which equals 16 inches square. Okay, so that, and I don't have any other parts of the net. Now, if I had a different kind of solid that had a combination of triangles and squares, or different sized rectangles, or a hexagon and triangles, okay, then I would have more to do in this step. But since each part of my net is exactly the same, I've only got one figure to do here. All right, now, final step on this one, step 4, then, is to find the sum of all areas and, oops, hold on, and label. Okay. All right, so find the sum of all areas and label. So for this one, the cube is pretty easy. I know the area of one of these parts is 16, and there are 6 exactly the same. 1, 2, 3, 4, 5, and 6. So it's going to be 16 times 6, which equals 96 inches squared. And that is the total surface area of this particular cube, this particular solid. So let's make a quick little note here. Where did this 16 come from? That's the area of one square. Okay. Where did this 6 come from? Well, there are 6 squares on the net. Okay, that's what that means. All right, so that is the end of our notes. Finally, I know this. Now you know why I tell you we usually break this lesson into 2 days. It's a tough one. But that's the end of our notes for lesson 6.4. So let's take a look at our practice problems. Okay, so 6.4 practice problems. There's only 2 on here. And the first one is pretty simple to do. It's only asking you to sketch a net of this particular solid. Now, this is a really common net you'll see. And I'm looking at my figure here. It has a square base. It is a pyramid. And so I'm going to start by drawing the square base. Now, connected to the side, each side of this square is a triangle going up to this vertex, the point at the top of the pyramid. So it's very simple. All you have to do is draw off of each side a triangle. Now, a proper net means that all of these triangles would be exactly the same size. Are they going to be when I freehand this net? No. And I don't expect it will be when you do it too. Just do your best to try and make them as similar as possible, because in order for it to make a perfect pyramid, all of those triangles would be exactly the same size. But this is a good approximation of a net of this square-based pyramid. All right, that's all you had to do on that one. Now, find the surface area of this prism. There's a little bit more to this one, isn't there? Okay, let's remember what our steps are. First, I've got to draw a net, okay, of this. Now, the long rectangles here that you see are the four sides of this rectangular prism. So I'm going to draw 4, and they're the same size. I can tell because it's 1 foot this way and 1 foot on height here. So the rectangles and 13 long. So all of them, we should be drawing it so that they appear to be about the same size. Again, are they going to be? No, but we'll do our best. Okay, and then I have a square base and a square base at the top as well. And just like with the cube, you can attach these any old way you want. All right, so step 1 is draw the net. Okay, all right, step 2 is to record the measurements. So it looks to me like one of these has a length of 13 feet and it has a width of 1 foot. I'll put that there. Now, in addition to these rectangles, I also have these 2 squares, and they are 1 foot by 1 foot. Okay, I've recorded my measurements. You might want to pause and zoom in, and if you're using a tablet or something, I imagine they're a little bit hard to see. Okay, so step 3 then is to find the area of each of the parts from my net. All right, so step 3. Well, I have 2 different kinds of parts, these 4 rectangles and these 2 squares. So one of the rectangles is going to be 13 times 1, which equals 13. Okay, that's the rectangles. Okay, draw that. Right, now the squares are 1 times 1. They're 1 foot by 1 foot, which of course equals 1, and that's one of the little squares. Right, so I've recorded them. Now, in step 4, I find the sum of all the areas. So I have 4 of these rectangles, and they're 13 inches square in area. So 4 times 13. Let's see. 13 times 4, 12. It's 52. So all of the, oops, not inches, we're dealing in feet here, huh? All of the rectangles all together have a surface area of 52 feet squared. Now there are these 2 squares. One of them is 1, but there are 2 of them. So 2 times 1 equals 2 feet squared. All right. Now when I add these 2 together, 54, I'm going to have the answer for the total surface area of this rectangular prism. Okay, the total surface area. Oh, sorry, I was working out of frame a little there. There you go. All right, so the total surface area is 54 feet square, or 54 square feet, whichever you prefer. Okay, so that's your practice problems. Let's go ahead and look at your worksheet. Your worksheet, the first 3 are just to sketch the net. Okay, so it helps to sketch a net by thinking first about your bases. and then how are the other shapes attached to the bases. And then think of things you already know. You know, we've done this kind of shape, whether it's a cube or a rectangular prism, several times. So look at your notes and see how it would be. On this one here, it's still a prism. It's a triangular prism, but it has a triangle base and a triangle top and 3 sides. And they're not the same size. Notice that this side here is much bigger than this side and this side. So you can get your clues on the lengths of this triangle for the sizes of the rectangles. Okay, so just do your best. Again, you know I'm no artist, so I'm not expecting you to be, but I should see some kind of a reasonable drawing of a net of those. All right, the next 3 are again very similar to ones we've done either in the notes or in the practice problems. So remember your steps for finding the surface area. I need to see the steps. Draw the net first, then apply the measurements to your net, then start working it all out. If you need to use an extra sheet of paper, that's fine too. And then down here in the last of it is a word problem. Kyle wants to determine the surface area for a cube that is 5 inches on each side. So first you're going to draw a net of that cube. We've done that in the practice problems, or well, in the notes. Find the surface area of that cube. How could you solve this problem without using a net? This is just a description. This is a answer in words type deal. Think it through. I'm sure you can do it. Okay, so worksheet for lesson 6.4. Last is the exit ticket for 6.4. I don't give you the answers to this. Your teacher may use it in different ways, but I'll just show it. So the exit ticket has 2 problems. The first one is draw a net for a cube. That should be old hat by now. And the second one is find the surface area of this square-based pyramid, and we've done that in this video as well. So you should be well prepared for how to work this. Okay, so that's the end of lesson 6.4. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.